居没问题。那我们开始喽，可以吗 ？OK， 好，开始。
Good afternoon, everyone. We are the Chinese Foundation Secondary School from Hong Kong. Today, we are going to introduce our experiment, tissue paper tension test. Since we all use tissue paper in our daily life, it is important to know the tissue paper quality. However, it is difficult to know the quality of tissue paper because there are only two field tests about tissue paper. Therefore, we need to do an experiment to test the tissue paper strength. We will simply call tissue paper as tissue in the later on experiment.
First, let us talk about our aims and objectives of our experiment. Our aim of the experiment is to investigate the strength of the dry tissue paper by finding the breaking tension and the flexibility to calculate the force constant of different brands of tissue paper.
To choose the best tissue, we have to know about the structure of tissue. From this picture, you can see that there are numbers of fibers crossed within the layers which create hoses. Moreover, each layer crossed together which results in high porosity, which is specifically defined for the tissue paper as number, size, and distribution pattern of pores in the sheets of tissue paper.
Here is our experiment, which consists of two parts. The first part is to find out the breaking tension of the tissue, and the second part is to find out the elongation of tissue. These are the experimental materials we need for the tissue tension test. First of all, set up two stand and clamps and ensure the rod is horizontal with the use of level ruler. Secondly, cut the tissue into 3 equal parts. Thirdly, use adhesive tapes to stick the both ends of tissue to the ruler. Then fold the tissue into half along the middle of the tissue and hang the tissue on the metal rod. Use 4-meter rulers and binder clips to fix the tissue into place. 2-meter ruler on each side and binder clips should be distributed evenly. Next, use a rod to pass through the middle binder clips and the force sensor in order to hang the force sensor. After this setup, turn on the data logger and press the Set 0 button to ensure that the data is set to 0. At last, pull the force sensor downwards until the tissue tears, and observe the result and record the maximum reading.
For the elongation test, we need to find out how long the tissue can extend before it breaks. To have a fair test, we have to ensure that the experiment is carried out horizontally. Firstly, put a piece of tissue on the table. Secondly, put a metal rod on the middle of the tissue. Thirdly, stick two ends of the metal rod on the table using adhesive tape. After, put two meter rulers to the two opposite edges of the tissue and fix with adhesive tape. Then, fold the tissue together with the meter rulers to the other end. Next, put another two meter rulers on the edge and bind them with 3 bender clips. They should be separated evenly. Moreover, put the meter rulers in order to extend the tissue until it breaks. At the same time, a person will hold the rods on the end, both ends of the edge. At last, measure the extension of the tissue with the meter ruler stick on the or along this table.
In this experiment, we have several experimental errors. First is the clamping of tissue paper. It is hard to clamp the tissue tightly. Friction between the ruler and the binder clips may not enough. Make the ruler and the binder clips slip before the tissue tear. Our solution is to stick the clips to the ruler to tissue with adhesive tape to increase the friction between them. Next is the distribution of pulling force. If the pulling force isn't distributing evenly along the surface of tissue paper, the experiment results may not be accurate. Our solution is to cut the tissue paper into 3 equal pieces and multiply the results by 3.
Here are some of the graphs that we have obtained during the experiment in the Pasco data logger. These are the experimental results in the tissue tension test and elongation experiment for different brands of tissue.
By comparing different tissue results, the force constant of different bands of tissue. Winder has the largest force constant, while Tempo has the lowest force constant. In all, Winder is the strongest and Tempo is the most visibility.
Okay, you've done a great job. Okay, 有没有问题？
有问题吗？
So you mentioned about I mean you got the string or the tension. So for tissue, you want it. I mean the tension too high. You mean it's too hard. So may not be good when we try to use it to wrap our faces or this. So the number you get, how do you relate it to the comfortability? It's good to use it in wrapping our mouths or wrapping our nose. How do you have any value to quantify it? For the question, they have to decide on which usage are using it. From our results, because you are using all this pocket tissue, right? So this pocket tissue normally use it for wrapping our mouths, our nose. So we actually do not want it too hard or the tension too high. We probably want it a bit soft so that it will not hurt our mouth or our nose, right? If it is for this usage, we suggest to use maybe sensors or clinics.
I think that different kinds of tissue have different use in by different method. As you say that we now only using the pocket tissue to do our experiment because we think that the pocket tissue is the most one to use in our daily life because it is just in your pocket.
Okay, is there any way to improve your whole face about your experiment? How do you do that? Is there any idea?
Oh, excuse me, can you repeat the question?
You pull the force quickly, and I think maybe there's some problem about your whole face. You need to record the whole face. You just do that. I think there's some guy do that. Did that right? Okay. Is there any way to improve that whole face?
We can repeat the experiment for several times, or
But you did only 3 times.
Actually we have to do about 5 to 7 times. But for
Is it enough?
Maybe enough.
Okay, thank you very much. Okay.
谢谢。